Wideband Yagi-Uda antenna for V2V communication. The project is guided by Mr. J.T. Arun Rakesh, and this is the project content. We're going to see about objectives, introduction, proposed system, design equation, and design for 3D model and graph analysis. So the objectives of antenna is mainly with the design concepts. We have designed an optimization of Yagi-Uda antenna for V2V communication. With the Yagi-Uda antenna, we have increased the gain for the antenna with the improvements of the crucial by achieving the better communication, and we increase the bandwidth and reduce signal loss. To achieve this V2V communication, we include a very low latency for long range communication. This antenna is mostly fitted in the shark fin of a car or ambulance to communicate to other vehicles and interacting and reduce interface to a period of time. And next, I'm going to give about the introduction of what the Yagi-Uda antenna. Well, the percent of 5G application mobile communication is designed for high rates transmitters and rapid connectivity of multi-video application. Well, the dipole of Yagi-Uda antenna is renowned for its direction and characteristics. Well, we have improved the gain and optimized the passive elements, offering a coupling direction and communication within multi-meter wave frequencies. Well, with the help of Yagi-Uda antenna, this antenna is mostly used for long-range communication and for military vehicles and parameters. These requirements include several for reliable military communication, distance to healthy weapon and the Yagi-Uda antenna can adapt to 50 as to its battlefield conditions. So this was literature heavy antenna. But Dr. Aparna T. Veerappan R was converted a journal about a combat of Yagi-Uda and 5G communication, where the operating frequency of 500 GHz was reduced to transparent of 50 GHz per GHz. Well, Mr. Lee of 2019 was a dual band 5G antenna and it is dedicated for short range communication and scratch the band antenna for advanced telematic communication, where the operating frequency for is 2.7 GHz, where it is not reduced to dimension free, it is built for 5G communication parameters. Well, this is the extremely better for antenna. Well, external antenna is a free application. It is used to optimize for a supervised machine learning approach and help of a 3D model builder and Python sequence. With the argued optimization geometry array, it is use a variable of frequency operating 28 GHz, where 28 GHz represents a high radiation pattern. It can affect the human body and pregnant women while traveling in the vehicles and ambulance. And the VSW was at around 1.2 minus, and the gain is over 5.5 dB respectively. Where the performance of dual beamforming with the extreme array antenna is evolved in a 5G link for V2V communications, and it is also known for locations of the vehicles or space storage. Well, the extreme model is developed for Doppel shifters for pushing error to check the beam log, and for testing were used for the four channels of urban LOAs, urban NLOAs, and IOLAs and highway NOAs. It is mostly used for multi-range communication for long range and V2V. Where the proposed system was used to say reduce optimization and gain of it. Well, this is the proposed system actually. With the help of we have a new design, we have increased the gain and reduced the radiation pattern. So that with the help of the reduced radiation pattern, the human radiation can be affected, so they can easily fit in the card to improve the time frequency and reduce the latency for it. With the help of this, we adjust the parameter such as the element dimension and spacing and to achieve the desired specification. Similar to anti-radiation patterns, it is a matching for outperform metrics where it's a design equation formula. The first equation is for the effective radiation for particular leads to generate good radiation. But the second formula used for microstrip antenna, but used for diel and Constantine. Once W is found, the estimated length of AL is using. These are the antenna parameters for W is equal to V and FR is equal to resonance frequency and is not equal to permeability. And this is the effective length of the patch. H is called length of the substrate and L is called length. And this antenna parameters, F naught is for center frequency and N is for number of elements and LD is for driven element length, where S is a line spacing for the antenna between the dial picks, where there is totally 6 dial picks, LD5, LD6, and LD1, 2, 3, 4, where tan data is for lost as in substrate. That is also a design for antenna. And the length of the actually it has to be antenna's three dimension x dimension, y dimension, z dimension. And there is totally 7 dielectric length and the spacing will be dielectric 5 and previous element. One dielectric is different from other dielectrics, for example 0.5 mm to 0.6 mm. Well, design for M is number of elements. There is totally 7 elements. Well, the length of the dielectric one is 8.33 mm and the LDR two is 20.22 mm. So everything is about 20 mm ranges. Only the point mm is differ about each dielectric. Only it's about 40 20 mm range. But this is spacing between the dielectric 5 and dielectric 6 about 1 mm. The dielectric 7 is 13.90 mm and 6 is 13.6 mm. Well, the difference is reduced to 1 mm difference between. The x-axis, y-axis, z-axis dimension of the x-axis 23 mm and the y-axis is 298.4 mm and the z-axis 60.4 mm. It's again to trim the range of the size. Well, this is a microscope diode antenna. Why we use microscope diode antenna? Because microscope diode antenna directivity. This has to increase directivity by focusing on the radiation pattern. It has a specific direction. This increasing signal self is for desired direction while reducing the interface from other direction. Well, it is a focus on one direction. It will avoid direction from another direction. Well, it has a high gain. Gain antennas is used to high gain for how much power desired direction compared to the isotropic radiation. Well, Yagi-Uda antenna are designed to provide a high gain, making them capable of long range communication. That is why we choose Yagi-Uda for long range communication with improved high gain. Well, it is easy to install. Well, Yagi-Uda antenna is very simple and easy to install. There is no complexity of it. Well, this simple operation allows the antenna to point at a desired transmitted or receiver. This is the ideal application for antenna, such as rooftop application or TV reception or wireless point-to-point communication. Next, it has a low noise. Outdoor antennas generally have a low noise, which means they are likely to pick up a unwanted signals or interference with electricity. This is why we improve the signals and clarity of the signal. Compared design, Yagi data is simple design and it is not complex. It has a small patch and low profile design. It is intended for tight areas and tiny devices. Well, it is a ruggedized antenna. It can use to combat vehicles and very tiny parts. Well, it is easy to design and low cost. The PCB fabrication techniques are low cost chips and is compared to other antennas. And frequency range. The antenna substrate material is cut size and other design. Multi microstrip antennas can manufacture by through both frequency ranges. And this is a design antenna where the left hand side is about the top view of the antenna where then totally you can see there is a 6 dielectrics and one reflector and dielectric. Each have 0.5 mm. And the right side you can see it is the side view of the antenna. You can see tan direction everything. And it's a 3D model of antenna. The new design is the Yagi-Uda antenna. It has had a frequency range of 5.6 gigahertz. And next, it's a system with sequence of 28 gigahertz, where there is a high radiation pattern and very short range communication. Where in our new Yagi-Uda antenna, we have reduced the gain up to 5.6 gigahertz, and with a high direction, a very directivity, and we reduce the radiation. And this is a fabricated model of antenna. Well, the fabricator that's it is 5 diodes, and we have tested the antenna in the microstrip network field analysis. We tested the antenna, and finally the result controls. The proposed Yagi-Uda antenna for VT communication is to reduce the latency and the radiation pattern from the existing antenna. The gain of the antenna is 10.5 mm, and the VSW is 1.05, where the return loss is minus 31. Well, this is the return loss of simulator antenna. Well, the operating frequency is 5.7 gigahertz. The return loss is minus 31. So again, we have reduced return loss. And the result of return loss is and the VSW value. The VSW is 1.05 FM. Here, reduce the VSW so that we can improve the gain and the directivity of antenna. Where this is the gain of the antenna, which operates 5.7059 gigahertz. The gain is about 10.55 mm. So with the help of the high frequency gain with the short range, we have reduced the radiation to affect the well, this is the radiation pattern of the antenna. It's a far field of the component of ABS and output of gain is